Here are two 10 nanometer diameter silver nanoparticles, and we're going to move the particle on the right a little bit closer to the particle on the left. So here you'll notice that they're separated by just a lattice constant. The bottom images represent zoomed in images of the top two images. And then we can also use the beam to induce particle convergence and coalescence. So the particles here have coalesced via an expanding twin plane at the boundary. And if you keep moving the beam across, eventually these two particles will merge into a single larger particle. So dimers have been used quite a bit in the literature as very sensitive SERS, surface-enhanced Raman platforms. They've also been used as tunable nano antennas, where you can basically tune kind of the receiving and the emissive properties of these optical antennas. And they've also been used as molecular rulers. So there's pretty significant reason to want to explore their optical properties, particularly as a function of interparticle separation. So we can switch over to EELS, electron energy loss spectra, and basically measure the optical modes. So here are two 10 nanometer silver nanoparticles separated by a 3 nanometer gap. And we wind up with one peak when we're putting the beam basically right next to the particles here. So we're going to be exciting this longitudinal surface plasmon resonance. So this one peak indicates that for such a large interparticle separation, our particles aren't very closely coupled. So we're just winding up with a peak that looks very much like a single 10 nanometer nanoparticle at about 3.2 or so electron volts. Now when we bring the particles closer together, this single peak splits into two different modes as the particles begin coupling. One of these modes, at lower energies, corresponds to a bonding dipolar resonance, where you have a very strong electric field intensity in between the gap of the two particles. This is what's generally used in single molecule SERS measurements, or also in molecular ruler experiments. And if you plot out how